Hi, everyone. I'm Ben Clark. This is Bryan Housel. We're the Rapid Editor dev team, the entire dev team. We've had people ask us how many others are on it. It's just us. So we're here to talk to you about Rapid V2. We're real excited. So what is Rapid? Well, we're going to cover that. It's an OpenStreetMap editor. It's based off ID. It's web-based. So what we've been up to lately is we had a launch of Rapid version 2 last month or 2 months ago in April. We're going to talk a little bit about some data set growth that we have through our partners at Esri, where we have an API integration with. And also we're going to talk about some challenges that we encountered building V2 and also some new features, future plans. All right. So what is Rapid? It's an editor for OpenStreetMap. Surprise, surprise. It's originally based off ID. It runs in a browser. You can just fire it up. Go to rapideditor.org right now. The value add is that we rewrote the renderer to be really a lot faster than the old version 1 of Rapid. And there's a whole ton of data and data sets that you can just get off the shelf that are curated and QA'd by Esri. They're tagged correctly, they're licensed correctly, so you just add them to your editor and go. So you can see last year's State of the Map talk on YouTube by also us. And previously at State of the Map Tucson, we debuted a V1 sort of alpha of this editor where we showed this exact performance demo. And there was a single audible gasp in the room when we showed this, which kind of fueled me creatively for like the next 9 months. We knew we were onto something, right? It's a lot faster than it used to be. And it was really kind of funky. Previously, we would occasionally measure our performance in seconds per frame, which is just not good. Next slide.
Yeah, sure.
Yeah. So again, I know. Thank you. That will fuel me for the rest of the year. I appreciate that. So we showed this rendering speed, and then we talked a little bit about sort of the tech behind how we were able to do this, right? And so why would we do this is, well, data isn't getting any less complex over time, right? State of the Map, OpenStreetMap 10 years ago had a lot of missing data. You could go to a place and ID and other editors would render just fine. But now there are urban areas that are so well mapped that Rapid V1 was just completely unable to keep up with the level of features we had. So Bryan did some presentations last year about like the differences between what we had to do in the DOM before and all the editing that had to happen on the fly for the renderer to do its thing. So we're going to talk a little bit about some of the challenges we encountered over the last year while we made this kind of a reality. So on to the release. It was successful. We got Rapid V2 out, and we are working with the hot team, thank you, Ramya, to try and get V2 built into Tasking Manager. We had a couple of beta programs. We got a lot of feedback from the community. And so we have a new logo. We have a new name. Well, same name. We just lowercase the d first, so we won't get into it. And yeah, next slide.
Oh, because we also have a lot of people we want to thank for this. I put this in the speaker notes. I want to give some shout outs, especially to Abhishek Tripathi, Eduardo Nirhat, Christopher Bidal, for helping us stay focused on the mission. Because it can be easy to just kind of let things go on and on and on. Taylor Smock, Martijn van Exel, Alex Anicelli for doing a ton of testing, and Anna Bryant and our design team at Meta. So, they really helped this new website get together and the logo. I mean, everyone just really came together to make this a success. So we're, still super excited about it. Cool. What else?
Oh, looks like we lost a couple of emojis.
We just lost some emojis.
The conversion from Google Slides. So the new pedestrian data sets from Esri are very cool. That's supposed to be a tree emoji, actually. So we have a new tree data set. We have some open data sidewalks data that you can just add straight to the map, either in Boston and Seattle. There's 170 data sets. They comprise hundreds of millions of features across mostly, unfortunately, the North America, a couple global and worldwide data sets. There's a talk coming up right next. So if you have data and you want to bring it into our API integration, stick around, stay right here.
Okay.
All right, I'll turn it over to Bryan. He'll talk about some challenges we had implementing the renderer.
All right. So all this stuff I'm going to talk about, is replacing stuff is hard, right? I mean, it says that up there. In our last year, we showed how we could build a faster renderer, but the thing that we showed off in Tucson was really not a functional editor. Like the point, add line, none of that stuff worked. And basically, I'm going to talk about like what we had to replace. The stuff on the left, the CSS, the SVG, and the D3. It's not that these are bad technologies, but they do tend to shuffle around the browser's document a lot. And when you're changing the DOM in the browser, you're just going to hit this wall of performance where you just can't make it go any faster. It put limits on how much stuff we could put into the scene and how quickly we could update it. So the first challenge, no SVG, no CSS. So I'm sorry, I hate putting lines of code in a presentation. This is my own pet peeve, but whatever. This is the sort of line of code that would not work with our new renderer at all. It's basically saying select all the markers on the Mapillary layer, update them so that only the hovered one has the CSS class hovered. Sounds simple, right? But there's no more Mapillary layer. There's no more markers. There's no more CSS classes. All of this stuff went away. So we had to kind of find new ways of doing all of this in the new renderer. And when I say this sort of code existed everywhere, I'm not exaggerating. Hovering and selecting was completely broken a year ago. Drawing did not work at all. You could not snap lines to other lines. And a lot of our like parent-child sibling relationships that we need to maintain in OSM were just not working at all. So you could have things work where like you say, select a line, but select all of its child nodes along with that line. And so this would manifest itself in some really funny bugs. This was one that I got last year where like in the old renderer, we would just CSS class this point as being like, we're dragging it so you don't have to snap anything to it. And in the new renderer, we didn't have that anymore. So it was trying to snap to itself and it was just a big mess. The solution for this, again, sorry for the block of code. We ended up having to re-implement a lot of what the DOM and CSS does in our own internal scene graph. This took us several months to really figure out and make good. But you can see that we got all these internal data structures now of like feature has data, data has feature. Parent has children, child has parents. This is all stuff we have to keep track of for ourselves now that the DOM is not something we can use. Challenge number 2, we're calling this what changed. This is sort of a twofold challenge because this, again, took us a while to get right. We use D3 to keep track of all the data in the scene. And I don't know if you're familiar with D3. One thing that it does is it binds your data to the document. That's a fancy way of saying that as things enter, exit, and update the document, D3 knows what has changed and can update it accordingly. And D3 is really good at doing this. But I mean, at this point, we have no more document and no more D3. So this is all stuff that we have to start doing ourselves as well. It would manifest itself in bugs like this. I was obviously having a bad day and I just named this that GIF. But we moved the thing around and the child nodes just like don't go with it. The funny thing was that the child nodes were actually getting updated. They just were not getting redrawn because we didn't have a thing that said, oh, this has to get redrawn as well. And the solution to this was to actually add a bit more sophistication into our rendering code to kind of replace some of the work that D3 was doing for us before. So now what our renderer does is it keeps a single frame in flight. This is sort of a term of art, but whatever. And if you're familiar with old school renderers like Panda 3D or SGI Performer, you might know these terms app, cull, and draw. Okay, so app is the work that we're doing to prepare the scene, figure out what belongs in it. And then cull is removing things from the scene that the user cannot see anymore. And then draw is the work that Pixie does to convert that scene into WebGL. And so the idea here is that now we have a loop of code constantly running that is, waiting for the next browser frame so that we can do the next tiny little chunk of work to kind of move the scene forward. And it turns out that that's a very efficient way to do it. The browser is a lot more interactive and we're not missing things like those nodes, where they just didn't go along with the shape that got moved. So to wrap up, because of all these challenges I mentioned, the switch away from D3 and SVG and CSS, we're still missing some features from V2 that you might have enjoyed in V1. Not to worry, like all this stuff we are going to in the next few releases kind of put it back in, but you'll see that some things are missing, like certain styles, for disused construction. The animations, we don't have a way of really doing that yet. Styling of images, turn restrictions editor, unfortunately, we do not have that yet, and visual differences. So anything that involves styling or anything that involved maybe like animation, we're still putting it back. So finally, I guess I'm going to turn it back over to Ben. Ben's going to talk about some of the new features that we are working on, but then a problem statement. So,
All right.
yeah.
So as I said before, map data is not getting any less complex, right? So you can go to a place such as like just around here, you can look at OpenStreetMap's data. There are no obvious gaps. You look at a piece of satellite imagery and all the buildings are there, the crosswalks are mapped, the roads are mapped. So what's an editor to do? Well, we can provide tooling and are hoping to provide tooling that will allow you better insight into map curation, not creation. And one way we can do that is to show things like 3D building height data. So just looking at the orthographic view, you might not be able to tell at a glance that there's a bunch of height data on all the building parts that you're looking at. But with a 3D viewer built here, this is actually implemented with the Mapillary inset map component. As you edit, the updates happen both in the 2D and the 3D map. So there's a whole bunch of things that we can do to help editors out by visualizing them in this way. Next.
Oh, does it turn into a video?
Oh yeah. Right.
Oh, there it goes.
Yeah. So as you pan around, you've seen updates, and we also did some minimal styling to show you what you've selected. And as you make edits, you can see them in real time as you zoom around. So this is pretty powerful. And honestly, if we tried to do this with Rapid V1, we were already so CPU bound that adding yet another canvas to render stuff on would have just brought your laptop would have started smoking or levitating, and you'd be having a bad time.
Do you have a shout out to me?
Oh, yes. So a shout out, especially to Tom McWright, who originally posted, I think in 2017, he implemented in Mapbox GL back then.
Yeah.
So we took that PR that he presented and sort of productized it and put it into Rapid V2. It'll be releasing soon. Next. So another thing we're looking at this half, this was hinted at our workshop yesterday, if you were there, is to take the Mapillary object. So for this scene, I've turned off all of the OSM data that would normally be here on this map. And we're just looking at what we get from the Mapillary API, was an image sequence that was taken from either a bike or a car, and all of the detected imagery or detected objects that we predict from that imagery as part of the Mapillary data pipeline. So we would like to be able to bring the capability to add these to the map in Rapid. So if you're interested in pedestrian or bike infrastructure, or if you just like mapping utility poles, then this will be a really nice boon for you. Next. All right, so we're looking at pedestrian focus features as well. So our colleague, Vinji, who is going to be talking more about this in a bit, has been doing some work to include pedestrian data sets, make all of the pedestrian navigation experience better using OSM data. So we have some new pipelines to improve predictions for our own Mapillary objects. We've got a couple new edit workflows that we'll be looking at for pedestrian nav data, and hopefully some new lints and checks to assist you while you do this mapping. So what's next? Very quickly, we're hoping to do quarterly point releases. And so we'll be releasing the 3D inset map that you saw soon, probably within the next couple of weeks. And at some point this half, we'll release the other features we showed. So we are actively working on integrations with both Map Roulette and Tasking Manager to get V2 into Rapid V2 into both of those apps too. And so hopefully in H2, we'll have the Mapillary object detections done as well.
Yeah.
Yep.
Call to action.
Call to action. Use Rapid, rapideditor.org/edit. You can use it right now. And it looks like we're out of time. So I would say, if you have questions, come find us at the meta booth upstairs. We'll be happy to answer them. We'll be around for the rest of the day.
Grab a sticker, grab some swag, just say hi. Thanks.
Time for a quick question?
Sure, from you, yes. From anyone, whatever. Yeah.
What's it?
No.
All right. Thanks, guys.
Thanks.
All right, thank you.